So if you are going to discuss about topology change in case of STP, topology change means you already build up a network. One STP topology is already built up. After that, if you are going to do any kind of changes, that kind of changes will known as topology changes. That might be the changes is happening by a network administrator, or the changes is going to happen automatically due to some reason, some problem or some link fail or something. All kind of changes you can consider like a topology change. In my network, if I am going to do like, if I am going to shut down a PC, the PC is connected to my switch and I am going to shut down that PC. In that case also, that will be considered as a topology change because one of my port in that device is going down. If your port is also flapping like going up or going down, some kind of things are also happening. At that case also, your device have to do certain kind of activity. So for that reason, everything your network is going to face or going to change. In that case, we can consider them in topology change. According to STP, if we are going to discuss about the topology change, then according to the scenario and everything, we are having three kind of topology change. First one is insignificant topology change. Second one is direct topology change. Third one is indirect topology change. Okay. So first of all, we will discuss with direct topology change, then indirect, then we will come to insignificant. Okay. So if we are going to discuss about direct topology change, then the scenario will be like, for example, I am taking one example for this. This switch number 1, 2, and 3. And you know, if this switch is your root bridge, then any link, this port or this port, any port might be your block port, and this will be root port because this port will have the lowest path cost to reach the root bridge, and each all ports will be designated port on root bridge. Or if this is coming your block port, then this will be designated port. So if we are going to discuss about the direct topology change, then what will happen if any link of a device is getting failed? Like I am talking about this device, and this link of this device is going down. Going down means that device is going to means lose its root port. Okay, or you can consider like root port of this device is going down, and another thing is like this device is already having a block port, and you know block port is alternate of root port. So in this case, what is happening? The root port is getting down, and this device is having a block port. So this kind of scenario, if a device is having a root port and block port, in case its root port is getting down, then this kind of topology change scenario will call as direct topology change, just because the device who is going to face the topology change, because this device will suffer now. There will be no change for this device because this device root port is working. But for this device, the changes is going to happen. This device is going to face the changes. So the device who is going to face the changes is also having a block port. In this kind of scenario, we can call this one as direct topology change. In this case, every time your network is facing a means changes or any change your network is facing, in that case, your whole network will be converged again. The whole STP process will run again, and everything, every election and everything will happen again for this device. Okay. So what will happen right now? To converge the network again for this device, it will take 30 seconds of time in case of direct topology change. Why it will take 30 seconds of time? Because this device don't have a root port right now because root port is down right now. This device is having a block port, and you know in block port the device can only receive a BPDU, and device don't have any capability to send a BPDU from the block port. But whenever the root port is getting down, then what will happen? This device will do a re-election. Okay, you will think like I am having only one block port, and my block port can also become a root port or designated port. Okay, so what it will do? It will do a re-election. For that re-election, again for this port, it will start from the disabled state to forwarding state. From disabled to blocking, in blocking state it will keep for just for some millisecond, but in listening and learning state, it will stay for 15 plus 15 seconds. The total time will be 30 seconds. Might be it can take 31 or 32 seconds if means the convergence is taking little bit more time, but exactly we will call them like it will take 30 seconds just to pass the state of STP from disabled state to forwarding state again. So it will do all the election, it will receive this BPDU from this switch also, and after doing all the elections, it will get to know like this port will become root port or designated, because this device is not having any root port right now. So in that case, this port can become a root port, which can receive the BPDU. So this is the scenario, this is the topology change kind of thing. In this kind of topology change, we can consider this one as direct topology change. Another kind of topology change scenario will also come, which is known as indirect topology change. Okay. So in indirect topology change, I am taking one scenario like this is switch 1, this is switch 2, 3 and 4. In this case, this is my root bridge. So it will be DP and it will be also DP. This one will be RP. This one will be RP. Or this switch, 4 number switch might be this port or this port. One will become RP or another one might become designated port or block port. So I am taking like this port is root port and this port is block port. This is okay. So right now what's happening? The link between switch number 1 and switch number 2, switch number 3 is getting down. Okay. So the link between switch number 1 and switch number 3 is getting down, and switch number 3 is going to lose its root port. Or you can say the root port of switch number 3 is getting down. In this scenario, if this kind of scenario is happening, then what will happen? Switch number 3 will think itself like it's a root bridge. And also there is a statement in STP like whenever your switch is coming up now, the first BPDU they will send before the election. Before the election, the first BPDU they are going to send. In that BPDU, they will send the root bridge ID and sender bridge ID as same of their own bridge ID. Why they are sending? Because first of all, till the election is not completed, everyone will claim like I am the root bridge. Like we are finding in election now, in our general election also, you will find like all the people they will tell like I will win the election, I will win the election. But after that, who is going to win the election? He is only the candidate who became the MLA or MP something. In this kind of scenario also the same thing will happen. Initially before the election, all the candidate will tell like I am the root bridge. And after the election completed, then after that only one switch will become the root bridge. So in this scenario also, what this switch will think, this switch 3 will think, he will think if my root port is getting down, then I don't have any path to reach the root bridge, or might be root bridge is down, he will think. Okay. So if the root bridge is down, then I can also claim like I am a root bridge just because I am having one designated port. Okay. So same thing now, if you are going to remove this link, then what will happen? This switch and this switch, there is no change, because this switch having all the designated port, or you can say this switch is having right now only one designated port. This switch is also having a designated port. The switch who is having the designated port, he can send a BPDU, because from designated port the devices will send a BPDU. Okay, so this switch will right now think like I am a root bridge, so it will send a inferior BPDU. The BPDU we are taking means initially we discussed like the best BPDU which is receiving on my root port, that BPDU called as superior BPDU, and this will be a inferior BPDU. Why? Just because nothing is completed. It's an incomplete BPDU, like this device is only claiming like I am a root bridge, and in that BPDU the root bridge ID like this the MAC address I am taking here, and the designated bridge ID both will be A and A, its own bridge ID. So this BPDU will send to this device. This device can receive a BPDU message on his block port. So in his block port, it will receive a BPDU. Last day also I told you, whenever a switch is receiving a BPDU, first of all it will store this BPDU in its buffer memory. In case of it's not receiving that BPDU for 20 seconds, what it will do? It will remove that BPDU or it will flush that BPDU. So in this case, switch 4 also stored that BPDU in this port. So what will happen? Initially, when this switch number 3 was sending a BPDU, in that BPDU, this is MAC address, root bridge MAC address is B. Okay. When he was sending a BPDU initially, when the link was not down, he was sending the BPD with root bridge ID of information of root bridge ID, that's B number switch or 1 number switch, and sender bridge ID or designated bridge ID of its own switch number 3 bridge ID. But right now again he is sending a BPD where the root bridge ID information is changed. So what will happen? Right now this switch will think like I am already having a root port where I am receiving a superior BPD, but still another one sending a BPD to me where the root bridge ID information is something else. So it will wait till 20 seconds to receive, till 20 seconds till the old BPD is stored in this port. So what will happen? This will keep discarding this BPD which is sending from switch number 3 right now. So after 20 seconds complete, what it will do? It will just flush the BPD what it is receiving from what it received earlier. Okay, after 20 seconds it will flush that BPD, and after flushing the BPD it can receive this, will accept this BPD after 20 seconds. So it wait for 20-second time to receive the BPD because it was having a old BPD here. So after 20 seconds again when he is going to receive the BPD, he will do a election for him. The whole election will complete like in the direct topology change I told you, like from disable state to forwarding state. Total 30-second time again it will take to do all the election. After the election, if he is thinking this is the best BPD or the best bridge ID switch, this switch is having the best bridge ID, then he can consider like a root bridge, or else again if he is thinking the root bridge is best, then he can make this one root port, this one will become the designated port. So in this case the total time, first 20 seconds he wait to remove that BPD from the port, again 30 seconds to do the election. So total time will be 50 seconds. So in case of indirect topology change, what will happen? The total convergence time will be 50 seconds in this way. So in direct topology change, what was happening? The device who is going to face the topology change, he was having a block port. So he was considering like if I am having a block port, then I can make that block port as a root port. So he was only doing the re-election for that. But in case of indirect topology change, the switch who is facing the topology change or who is suffering the topology change, he was having a designated port, not a root port. So he was unable to take a root port. He was just claiming that I can also become a root bridge ID. So for that reason, all the process what I told you that happened, and 50-second total time will be used just to pass the STP states. Then again one more topology change is there, that's insignificant topology change. In this kind of topology change, our topology will be this is my access switch or any switch. It's already created one topology like that you can understand, but this is a end user. My PC is connected to this port. So in this case, what is happening? My PC is going down. Okay, and going down and coming up like that. You remove this cable from this port and again you connected, or this kind of things you can understand. Because the port which is connected towards my end user, that port is suffering a flap or suffering a changes. This kind of changes known as insignificant topology change. If we are talking about insignificant topology change, then there will be no effect for the switching network. The switches connected, they will not do any kind of election or anything, nothing will happen. It will be same like what, but only the election will happen for this port. Again, this port will pass the STP states from the disabled state to forwarding state. So you know now whenever you are going to connect your cable, so first of all you will find some amber color light or orange color light on your switch. So for after 30 seconds the port light will come to green. So if your port light is showing green, then it's in forwarding state of STP. If it's showing orange, then something is happening in STP, like might be recently you connected the port and all the states I told you na, that states are passing by the port. That kind of things or election kind of things are happening for STP. Basically you can consider like from disabled to till learning state, the port light will be in orange color. Sometime whenever it will reach to the forwarding state, then what will happen? The color will be green. So green means you can now send data, send and receive data. Everything is fine right now. Okay. So this type of topology change is known as insignificant topology change. If you are having any doubt or question, you can ask right now. So after that, we will go ahead. Anyone having any doubt? Then we will discuss like if this kind of topology change is happening, then what will happen or how can we prevent the timings. Just because you know na, if I am talking about insignificant topology change, so just because sometime you are in a data center, what happened, you just touch the ethernet cable or something happened, just for that reason that ethernet cable got flooded. Just because of that, the user who is connected, he was sending some data towards someone, the data communication will be fail for 30 seconds. So this is the issue now. So the user is going to suffer for that. And if I am talking about direct topology change or indirect topology change, in that case, what will happen? Might be in direct topology change cases, all the users who are connected to this switch, all will be suffered for 30 seconds. And might be also sometime it can also happen the whole topology can be suffered. Like if one of your root bridge device is going to down or something, na, then whole the topology converge will start. In that case, what will happen? All the devices will be down for 30 seconds because all will do election. The data communication permission will not be there. In case of insignificant topology change, also this can happen. Like your network or the devices who are connected to the switch who is going to face the topology change kind of things, they might face communication issue for 50 seconds. So these are the issue. Our users are going to suffer for this. So if again and again this kind of issue are happening, like I told you, insignificant topology change or this kind of topology change, what will happen? If your physical cable is having some issue and it's getting flapping again and again, it's going down and coming up, going down or coming up, then what will happen in that case? This device can totally stop working. It's giving coming to forwarding state for few seconds or few minutes. After that, again it's going down. Everything. So users are going to suffer. So how can we reduce these timings or these convergence timings right now? We are having several methods to do that one. First of all, one method is there that's known as Portfast. Okay. So Portfast means, from the name you can understand, Portfast means we are going to make fast convergence on a port. So just come to the insignificant topology change scenario. If your device is connected to this port, by default, if any changes are flapping, any kind of changes happening to this port, it is taking 30-second time just to pass the STP steps. But if you are going to enable Portfast on this port, so what will happen? It will skip listening and learning state in STP directly from disable to blocking, and then directly it will come to forwarding state. The two states or two forward delay timer it will skip. So in millisecond the port can come up. Just it will spend few milliseconds in block state just to check if loop is there or not. After that it can automatically come up suddenly. Okay. So if you are going to enable Portfast, then two methods are there. Three methods are there. It's always suggested you should enable Portfast on a port which is connected towards your end user. Else you can also configure Portfast forcefully for a trunk link. Every time you are going to configure Portfast, then you can by default it will enable on access links. But if you want to configure Portfast for a trunk link forcefully, you can do that. I will also show you the commands. Then the next thing, if you want to enable Portfast globally for all the access ports, one Portfast default command is there. You can run that one. Then what will happen? All the access ports will become will configured with Portfast by default. In logical scenario, I don't know it will work or not, but still I can show you. Okay. So I am going to switch 3 right now. 1/0 is connected to end user. Okay. If we are checking this port right now, this is in forwarding state right now. This is a designated port. All the ports connected to our end users, that will be a designated port. How they will become the designated port? It will happen from a port, STP will try to send BPDU continuously. Okay, it will send BPDU towards a port till 10 BPDU it will send. Okay, after that, if it's not getting any kind of response or it's not receiving any BPDU, then what it will do? It will just make this one. It will just consider like this port is connected to a end user, and it will make this port state to designated port. So what will happen whenever you are finding any access port, any device connected, all the port will be designated port by default. Okay. So I am going to Ethernet 1 by 0 and I am making it shut down. Let's see right now what is the state of. Okay. So right now 1 by, where is 1 by 0? Okay. Sorry. I have to now shut down the fan. You can see 1 by 0 is in listening state right now, passing the states. For some time it will be in listening state, then it will come to learning state. Okay, right now you can see this is in learning state here. So after completion of 30 seconds, it will come to forwarding state. Okay, right now it's in forwarding state. So it took total 30 seconds to come to forwarding state. This is your port priority. I will also discuss about that. So this port is in forwarding state right now. So you know, like I just did a flap to that port, or I make that port shut down and not shut down. So after that, it's taking 30-second time. And again, if I am going to configure Portfast for that port, so inside that port, I can do configure Portfast. Like I am going to configure spanning tree Portfast. Okay, you have to type. Tab will not work. Okay, so if you are going to configure spanning tree Portfast, it will show like one message what I told you. Portfast should be only enabled on ports connected to a single host, means only on access port. Connected hubs, like some warning message it's giving. If you have connected one hub to that port, then you should not enable Portfast. What is the reason for that? If you are going to enable Portfast here and you connected one hub, after that if you connected one switch, so what will happen? In Portfast port, if the switch is receiving any BPDU, the switch will also send a BPDU. Hub will replicate that BPDU towards the switch. If on Portfast port we are receiving a BPDU, then the capability of Portfast will be, that port will lose the capability of Portfast. So in that case, what will happen? Again, the switch will take 30 seconds to come up. So for that reason, it's showing some warning to you. It can also create some temporary bridging loop kind of things it's showing. Then, okay, it's showing the same thing like I told na, on access port only you can configure the same thing. It's showing Portfast has been configured for Ethernet 1 by 0, but will only have effect when the interface is in non-trunking mode, because by default Portfast will be enabled only on access ports. Okay, right now we enabled Portfast. The same thing I am going to do right now. Shutdown and no shutdown. Okay, right now I am going to check the status. You can see this port is by default in forwarding state. It's not passing the listening and learning state. Directly it's in forwarding state. And if you are going to check this type, then extra keyword added like edge. If you are going to make any port edge, if you are going to enable Portfast on any port, then the extra keyword will added like edge, and that port will also called as edge port. In RSTP directly the port will call as edge port. Here if you are going to enable Portfast, the port will call as edge port. So if you are going to check the STP status, you are finding any port with edge, then you can understand like Portfast is enabled for that port. Then another command is also there. I am going to remove the Portfast command from that port. No spanning tree Portfast. Okay, so right now it's not showing any kind of edge. So I am going to enable the Portfast for in global mode. So I have a command spanning tree Portfast default. Oh, that command is not taking. Okay, this command is not working here. I think on packet tracer it will also work. This is a iron image, so for that reason I think it's not working. So you have a command spanning tree Portfast default. If you are running this command, then it will enable port first on all the ports where all the access ports where users are connected. By default, it will enable. This is the command, global command. Oh, this is working. It's not showing in option, but still it's working. But it will get effect or not, I don't know. Okay, it enabled on all access ports. At that moment, I was only able to see on one port, but right now it enabled on all the ports. So this is the command. Spanning tree port first default. This is the command. You can note down this command. If I am running any command, now just note down it with a notepad or anything. Okay, you can also enable this command. And the rest thing in our topology, I also want to do the same thing for trunk ports only. Trunk ports also. So we are having so many ports like 0 by 3, 0 by 2, 0 by 0, 0 by 1. I think I haven't also configured that trunk link. So at switch 3, if I am going interface range Ethernet 0 by 0 to 3 are my trunk ports. And I'm just manually switch port trunk encapsulation .1q switch port mode trunk. Okay, manually I'm going to make them trunk port. Do show interface trunk. This is the command to verify the trunk ports. How many trunk ports I am having? So here you can see I am having total 4 trunk ports. So I just want to enable port fast for these ports also. So what I can do? I can go to the same command, range command, then spanning tree port fast. Then you have to type one more command that's known as trunk. Okay, it's not showing after question mark. I don't know why, but it's working. Okay, this command you can run if you want to enable port fast for trunk ports. So we can flap our trunk ports to check if it's working or not.
Saubhagya, this okay. In trunk port, when you enable, still it will receive BPDU, right?
It will receive.
So will it help anything here?
Help means?
Will it put the port into forwarding state in milliseconds, or it will wait for 30 seconds?
No, it will not wait for 30 seconds. Directly it will means come to forward state.
Okay.
Okay. So for that reason he given na forcefully you are going to make the trunk port, so the behavior will also change na.
No, but in the previous warning, it was showing once you enable a BPDU, once you enable a port fast, when it receives the BPDU, that effect will change.
See,
it will not work with the port.
See, if you are going to enable trunk port, enable that port fast for all the trunk ports, now there might be a chance of becoming loop also.
Yeah, that's correct.
Because you
but
know.
in the
tell me.
In the warning, it showed when you enable the port first time, it showed right. This will affect only if the port does not receive any BPD. Just go up, no? Go up.
Okay, last message you are telling when I was enabling for that access ports.
First message.
This one you are telling.
This one. See.
This one. See, I told you.
Only affect when the interface is on non-trunking mode.
I told you na before coming to the configuration part. I told you na by default if you are going to enable port fast, it will only work for that access port. But if you want
it will only work for access port.
Yes. But if you want to configure the same for trunk port, now then forcefully you have to do. For that forcefully things, I enabled that port fast and I use one more command.
Forcefully, wherever we require, we can do. Like we are sure that maximum there is no probability of loop.
We have to mention trunk, but it's not suggested because if you are going to do this one, then there might be a chance of loop. Because you know, na, in listening state, all the elections are happening. If it's already a converged network, means already all the election completed, then it's fine, you can configure. But the thing is, like if a new election, any topology change you are facing, a new election is going to happen, in that case, you might face some loop kind of scenario. Might be your switch will unable to do all the elections properly. Okay. So it's suggested.
And one more thing, this is to Jay Babu. Maybe we'll take break by 10:30, right? So I want Jay Babu to summarize yesterday and today's thing after the break. Not a whole. at least some sort of headings and some sort of things so that we can understand how much we understood of your yesterday and today class.
Okay.
Jay Babu, so after break, you please summarize whatever happened yesterday and today here. Then we will continue, okay? Hello? Jay Babu, are you there?
Just a second, I'm taking one
Okay,
call.
you can continue, Mr. He is unable to
Just a
unmute
second.
or something like that.
Okay, I'm just taking a call. I'll disconnect. No problem. Okay, he's online or okay. So shall I start?
Yeah, you can continue, Mr. I think.
Okay. So the next feature we are having that is just a second. Hello. Sorry. हेलो. अच्छा, आप एक काम करो ना, आपको एक चाय का दुकान दिख रहा होगा. आप देखो, आप वो जो एक आईसीआईसीआई का एटीएम है ना, उसके फ्रंट में एक चाय दुकान है, दूसरे तरफ रास्ते के दूसरे तरफ एक चाय की दुकान है. हाँ, कॉर्नर में एक चाय का दुकान है. आप वहां पे जाके दे दो, मैं थोड़ा बिजी हूँ, आप वहां पे जाके दे दो, ठीक है. हाँ, उनको वो जो अंकल एक होंगे चाय की दुकान में उनको दे देना, ठीक है. हाँ, मैं पहचानता हूँ, कोई दिक्कत नहीं, आप उनको दे दो, वो पहचान लेंगे. आप मेरा नाम ले लेना, वो पहचान लेंगे, ठीक है. चलो. ओके. सॉरी, आई गॉट ए कॉल फ्रॉम ए कॉरियर. Okay, so next feature we are having, that's Uplinkfast. So first one we told Portfast that to reduce the convergence time in insignificant topology change. But in case we are facing any kind of topology change like direct topology change, to reduce the 30-second time in case of direct topology change, we are having one feature that is known as Uplinkfast. Okay, the same topology I am taking will be my root port, this will be my root port, this will be my designated port, this will be my block port. So in this scenario also, this port is going down. My root port is going down on switch number 3. So if you are going to enable Uplinkfast on switch number 3, then what will happen? After enabling Uplinkfast feature will always keep tracking on the block ports. So in this switch, what will happen? Uplinkfast will track this block port always. Whenever your root port is getting down, suddenly it will make that block port as root port, and it will skip all the state timers, like that for two forward delay timers your device is going to use in listening and learning state. It will skip both the forward delay timers. Suddenly it will make this block port as root port. So if you are going to enable this feature, then it's suggested like you should enable this feature on access layer switches only. Always suggest like if you are going to do, because you know na, as per our means as per the Cisco suggestion kind of things, your root bridge should be in the distribution layer, and other switches will should be in the access layer. So in that case, it's suggested like if you are having a access layer switch, then you should only enable this one in access layer. Then he called me. Just a second. Hello. हाँ, जल्दी जल्दी दे दो भाई. हाँ अंकल, वो मेरा एक कोरियर है, मैं चाय पीने के लिए जब जाऊंगा ले लूंगा, ठीक है. Okay, so for this reason only it's suggested like if you are going to configure this feature, then you should configure this one in your access port. So sorry, on access switch. Let it. So I am going to configure this one. going to remove the old configuration. Okay, no spanning tree port fast default shows spanning tree. Okay, I've removed all the old configurations. Right now for the trunk ports, I am going to configure this one. Okay, interface range, spanning tree, Uplinkfast, not giving the command here. Okay, we can do one thing. Just a second. Okay. You have to enable this command in global mode. Okay. So in global mode, I am going to run this command spanning tree Uplinkfast. It will enable Uplinkfast for all the trunk ports. Okay. If I am going to check the source spanning tree command right now, this is the scenario. So what I will do, I will just try to flap these ports like shutdown and no shutdown. Okay. Let's taking listening and learning state now for which port? So by 2. Oh shit. Just a second. It's having a block port. So we can do one thing. Ethernet. Uh, Sorry, I did something wrong. I got little bit disturbed. Okay, this is my root port. I'm going.
Done for port 3, I think.
Uh-huh.
You done for port 3, I think.
No, I shut down all the ports. Okay. I'm going to shut down my root port right now. So if I am running that command do source spanning tree, so you can see suddenly this 0 by 3 port was earlier block port. Okay. So right now it became root port suddenly without taking any more time. Okay. It became the root port. So it means this is working. So if you are going to enable that Uplinkfast, then what will happen? It will always keep tracking on your block ports, how many block ports you are having. If your root port is getting down, if you are having multiple block port also, then what will happen? According to the best port, which is your best block port, that block port will become your root port. Any confusion? Well, I got that call now, so I got little bit. Okay. Then third, we are having one Backbonefast feature. So it will basically skip 30-second time in case of indirect topology change. If you are going for indirect topology change, then indirect topology change basically will take 50-second convergence time to do the reconvergence. But if you are going to enable Backbonefast, then what will happen? In case of indirect topology change, the convergence will happen in 20 seconds. Still, it will take 20 seconds. I am taking the same scenario. 2, 3, 4. Okay. So for this switch, this is the root port, this is the designated port. Again, the same thing happening. Our root port is getting down. So what it will happen? So suddenly, in this case of in case of a Backbonefast, what will happen? This switch will send a BPDU. Okay. Till the time this switch is not not removing the BPDU from this port, will not receive the not accept the BPDU. What I told you in case of indirect topology, the same thing will happen. Till this switch will wait for 20 seconds to remove the BPDU from this port. But once the switch remove the BPDU from this port, again the reconvergence will happen suddenly. Because what will happen? Suddenly, whenever this switch is receiving the BPDU from this port, it will also send a BPDU quickly. So whenever this switch is going to receive the same BPDU, suddenly it will do the reconvergence and all the states of STP will skip. That 30-second time will skip. So in this way, you are going to save the 30-second in case of topology. Just because this BPDU edging timer, this switch is still waiting 20 seconds to remove the or flush the BPDU from the port. So for that reason, this switch is receiving, waiting for 20 seconds to receive a BPDU from another end. Once it's receiving the BPDU, suddenly it will do the convergence. If this port want to become the root port or designated port, whatever it will do, and suddenly everything will happen. So in this way also we are going to skip the 30 second from discarding to that forwarding step. Two step will be skipped, that listening state and learning state. Okay, but still in case of PPST plus or CST, in case of indirect topology change, still we are going to spend 20-second time. There is no way to skip this 20-second time. This one also, if we are going to enable on switches, I'm going to remove that Uplinkfast, spanning tree, Backbonefast. You have to run this command. Okay, so I think we are having so many links. So this is not a scenario for Backbonefast. We can do one thing. We can shut down some links. What I will do show spanning tree, which ports are 0 by 2, 0 by 3 connected. Which one is our root bridge, I think. Okay, I will do one thing. Spanning tree, VLAN 1, priority 0. So this will become the root bridge right now. So I will only enable 2 ports on this switch. Interface Ethernet 0 by 3 will be shut down, and interface Ethernet 0 by 1 will be shut down, and interface Ethernet 1 by 0 is access port. Do show spanning tree. So which port I told you that 0 by 2 and 0 by 0 are right now available. So 0 by 2 and 0 by 0. 0 by 0 is a designated port. Where is 0 by 2? Okay. So this is my designated port right now, and this one is root port. Okay, we are having 2 ports right now. So 0 by 2 is connected according to our topology also. This port is right now root port, and this port is our designated port. So right now what we are going to do, we are going to shut down our root port. 0 by 2 port is getting down, which is our root port. So what is happening right now, we will see. Do show spanning tree. If you are running that command, still you can see 0 by 0 port is a designated port. Till 20 seconds it will be a designated port. After 20 seconds, again whenever it will receive a BPDU message from other end, it will become root port or something, whatever it will become, See, after 20 seconds it became root port quickly. It's not going to spend that 30-second time right now for passing the states in STP, but still it's became the root port. Okay, so till this, if you are having any confusion or doubt, you can ask. We'll take a small tea break. Anyone who want to offer a tea also can offer.
Jay Babu is there?
Jai Babu, you there or?
Hello.
Yeah.
I'm there.
Jay Babu, after break, you have to summarize the thing yesterday, whatever he told, and today.
Okay.
Okay. Maybe not in detail, but at least somewhat.
Okay, sir. I will.
So based on that, we will go forward. Okay, after this.
Because this
Take a break and prepare that. Maybe after that.
Okay.
After break, you can talk. Okay.
We are also not going to take that much time for RSTP, just because if you understood that topology change things now, and this Uplinkfast and Backbonefast things, then you can understand RSTP quickly.
Okay.
So, are you facing any, you are having any question or doubt? You can ask.